Hi. Today I'm looking at just some more conversion problems. I'm going to do a couple out of the book, but the section where I'm at is the Section 3 Formative Assessment on page 89 in the textbook. And so if you want to go ahead and look at those problems before you do them with me, you can either just stop the video after I go through what the problem is, or you can go and try to do them now and then just fast forward to the end to get the answers. So I'm going to do number 5 today, and it's 2 parts, but I want to skip back to number 4, where it says, as I quote, "To 2 decimal places, what is the relative atomic mass and molar mass of the element potassium?" And that's an interesting question. So the relative atomic mass of potassium is measured in atomic mass units, or AMU, which is defined as 1/12 of a carbon-12 atom. And so what they're asking you for is the same number for potassium. I believe it's 39.10 is the average atomic mass in potassium. So the relative atomic mass is delivered in AMU, so it's 39.10 AMU, whereas if they ask you for the mass of 1 mole, that's going to be that number in grams. And so it's one of those things, it's not anything, I mean, we're not going to be measuring anything in atomic mass units, but it's one of those things that might trip you up on an exam or later on in a college course. And if you just remember that molar mass always translates to grams. But let's look at determine the mass in grams of the following 2 moles of nitrogen. So they give me 2.00 moles of nitrogen, like that. And so what I realized first is that's 3 sig figs. So I'm just going to be reporting 3 sig figs. This is going to be a multiplication or a division problem. And I have nitrogen. So, and they want to put that into grams. So I know that 1 mole of nitrogen is 14.007 grams of nitrogen. You can look that up on the periodic table. And then that also equals 6.02 times 10 to the 23rd that of nitrogen. And we're not going to use that Avogadro's number this time, but I'll just write it just because it's a 3-part, that 3-part ratio will get you about anywhere you want to go. So in this case, I'm going to write my moles, 2.00 moles of nitrogen. And then since I have moles here, the mole goes on the bottom because I'm switching out of moles into grams. So 1 mole of nitrogen is 14.007 grams of nitrogen. I'm going to grab my calculator here, and oh my gosh, it's going to be 28.014. That's my prediction. I love doing the math in my head. So 2 times 14.007. Okay, 28.014. Now, since they started us out with 3 sig figs, so I get that as my answer. And then you definitely take the 28, that's 2 sig figs. And then this 0 here, if you report it, it is since there's something here, that's going to be significant. So if we report it with significant digits, it's 28.0 grams of nitrogen because the 1 doesn't round up, and that is 3 sig figs. So that's pretty simple. So that was the A part. And then the B part is they give us 30, 3.01, I was already thinking of the atomic mass of chlorine. 3.01 times 10 to the 23rd atoms of chlorine. And then I'm going to do the same thing. It's 1 mole of chlorine equals 35.45 grams of chlorine equals 6.02 times 10 to the 23rd atoms of chlorine. And I'm going uphill again, but you're just going to have to deal with it. So here, the problem stated they wanted them both to be in grams. So this time I'm not going to use the moles, I'm going to use the grams because that's what the problem asked for. And then here, atoms. So I'm going to go 3.01 times 10 to the 23rd atoms of chlorine. And then I'm going to put 6.02 times 10, and I almost put the wrong thing on the bottom. So just goes to show you, no matter how many times you've done it, sometimes if you're not paying attention, if you're worried about how you look on your video or something, you might put your numbers in the wrong spot. But I fixed it. It's just going to look a little ugly. 35.453 grams of chlorine. And so this is a true statement. And the 35.43. It's 453. That's what I grew up using. So 35.45 grams of chlorine, there it is. And then the atoms cross off with the atoms, leaving us with the grams. So now this one, you got to be a little bit more careful with your calculator. So 3.01 times 10 caret. And when I say caret, it's because my calculator has that little thing to make the exponent. Times 10 to the 23 times 35.45. And then when I divide, I got to go parenthesis 6.02 times 10 caret 23. And even the fancier calculators that I've seen out there on the market, some of them are smart and will do the parentheses for you. You can only see the parenthesis there. But a lot of them will just do it. And then what you do is you end up with an answer that is like super large, because all you've done is divided it by 6.02 and then multiplied the whole thing by times 10 to the 23. But what I should get there is 1.77. Well, my calculator spits out 1.7725, and that's going to be grams of chlorine because I've done my setup correct. But I had, again, where is it? 3 sig figs right there, and so I take the 1, the 7, and the 7. And that gives me, when people talk about sig figs, some people are like, well, why don't you take the 2 and the 5? Because the number was not precise enough to have all the way out there. You might have been using a scale that only could measure to hundredths place, or it's just kind of like that. And we're always wanting to deliver the number that is most close to the correct answer. And so in this case, that is 1.77 grams of chlorine. I'm sorry for my little boo-boos here and here, but oh well. So that's mass to mole to mass and atom to mass conversions. We did a great job.